Hey guys, welcome to Pepcoding. Today we are going to learn a very interesting topic, bit manipulation. So this is first question, basics of bit manipulation. Here we would be given four operations and a number, and what we need to do is perform that operations. So first operation is that we need to set the ith bit. Second is unset the jth bit. Third is toggle the kth bit, and fourth one is check if it's the bit is set or unset. That is if it's on or off. So let's see how we do this. So I have already written for you what is set and what is unset. So 0 is unset, 1 is set. Okay, this is for sure. Now suppose this is my number for first operation we are doing. So number is 0 0. Let me rewrite it. Suppose I got a number 1 0 0 0 1 0 0 1 1 2 3 4 5 6 7 8, and there will be 24 zeros here. Okay. So now what we need to do is, suppose k is equal to what, say 4, and we need to unset this bit. We need to set this bit. It is already set. So let's take another example. Let's suppose this is the bit that we need to set. So what we'll do is we'll create a mask. What would be the mask? We'll put 1 here, and rest everything would be 0. Here 24 zeros. So now, if I do OR operation with this, then what will happen? 1 or 0 would be 1, 0 0 would be 1, 0 or 0, sorry, 0 or 0 would be 0, 0 or 0 0, 1 or 0 1, 0 or 0 0, 0 or 1 1. We needed this, we got this, 0 0 0, 1 0 1, and here everything would be 0. Why? Because if we do OR operation of 0 with any number, then we'll get the number itself. And if we do OR operation of 1 with any number, then we'll get 1 itself. So let me tell you what is basically OR operation. This was the OR operation. Let me tell you how we'll create the mask. So we have created this mask. So there is an operation called left shift. Let me first tell you what is left shift. So left shift is basically this operation. Suppose we are given this binary number and we need to left shift it. There are many zeros here. So in left shift, what we basically do here is we simply add. Suppose we're given this is n, we need to left shift it by 2. So we'll simply add 2 zeros here and remove 2 digits from the end. Okay. Oh, so I have put in the wrong symbol. So this is my left shift. Okay. This was just a revision. These are the basics you must know. What is left shift, right shift, OR and XOR. So let me just quickly show you all the operations. In right shift, same thing would happen. We'll remove 2 digits from here and add 2 zeros here. Now see one thing. It's not necessarily that I will be adding 0 only. Suppose my last digit here was 1, then I would be adding 1 here instead of 0. Here ones would be added. And if it was 0, so I would be adding 0. If I necessarily want to add 0 only, in that case I'll use triple shift operator, because in triple shift operator this neglects that what is the last digit, and it simply adds zeros to it. And one could be there could be a case that 1 is my last digit when n is negative, then only it would be 1, because that is for signed and unsigned bit. Okay, so I suppose that I am clear here. Okay. OR operation, basically we already know for both true OR operation gives true, for true false or false true. For at least if we have one true, our OR operation will give true, else it will give false only for when both the operations are 0. And is completely opposite. These operations we have already done. 0 is considered as false, 1 is considered as true. So I won't waste time on this. Let me just quickly show you the output. So here what we did was we simply created a mask and then we did the OR operation. How am I creating the mask? I just told you left operator. If I left shift 1 k times, then what will happen? There will be k number of zeros here. Okay. And here every bit is 0 only. Here it was 0, 0, 0, 0, 0, till 0. So I'll get the mask where I need to reach. So this is how operation 1 would be done. Let me take you. Okay. So let me write. We'll do it in functions. So let me just do function calls. So func1 n comma I. Okay. Public static void func1. Here I'll pass int n comma int I. Okay. Now let me create mask. So what would be the mask? Mask would be int t equals 1, sorry, left shift k times. This will be my I times. This would be my mask. Now I'll simply print println or. So n or t. Always remember one thing, that whenever you perform binary operations, keep that in bracket, because if there is any arithmetic operation, that would be performed first, because the precedence of binary operation is too low. So we need to do 4 functions. Let me just make 4 function calls. I, j, k, m. And 2, 3, 4. Similarly, 4 times, and 2, 3, and 4. Okay, so this is it. Here, instead of I, let's check j, k, m, so that we can understand. So now the next part was unset it. Unset the kth bit. So see, let's erase this. For unsetting, suppose I have a number 100, 100. Here are zeros till 32 bit, and suppose I need to unset this bit. Okay, so what will I do here is, see, I know that if I do its AND with 0, I'll get my answer. But if I do AND with any other number, then what will I get? If I do AND of any number with 1, with true, then I'll get the number itself. If I see, and what was the AND operation? If I do AND of 0 with 1, I'll get simply 0. If I'll do AND of 1 with 1, I'll get 1. Okay, this was the thing. So here, if I somehow do all the numbers 1 and this digit 0, if I create my mask something like this, then I'll simply get the answer, because this would be 0, everything else would be number itself, 0, 0, 1, 0, 0, and everything would be 0 here. So I'll get my answer, I'll unset it. So how am I supposed to get this mask? We know how to get this mask. 5 times 0 and here zeros. We know how to get this, we have seen in function 1. Now if I take its ones complement, in ones complement every digits toggle itself. So all these zeros will become 1, all these zeros will become 1, and this one will become 0. So I'll get my required mask. So let's code this. Okay. Function 2, what I need to do is need to perform AND function of my mask that I was making, that is I have named T, and simply do its ones complement also. This is the ones complement. This will do the work. Now in function 3, what I need to do is toggle. So basically, what does toggle means? Toggle means if it's 0, then I do it 1. If it's 1, I'll do it 0. So suppose my number was 0, 0, 1, 0, 0, 1. If I need to toggle this, then my answer would be 0, 0, 0, 0, 0, 1. Here all are 0, here all are zeros. So okay, let's see how am I going to do. So suppose here is 3, 4, 5, 6. So 26 zeros. Or say 26 zeros and ones. There are 26 digits, some zeros and some ones. Then here comes 0, 0, then 1, then 0, 0, then 1. I need to toggle this. Now here or let's just remove this. Just consider everything is 0 here. For your understanding, because it's first question, it's really basic. So what I need to do is I need to toggle this. If I take something, mask again, 1 here, and here everything is 0. So what performance should I perform so that I get the answer? See, there's an operation called XOR, in which when my values are different, then I get 1, and if they are same, then I'll get the answer is same. So if I XOR 0 with 0, I'll always get 0, and if I XOR 0 with 1, I'll get 1. So if I XOR 0 with any digit, then I'll get the digit itself. I can say that. If I'm XORing 0 with 0, I'll get 0. If I'm XORing 0 with 1, I'll get 1. So simply XOR this. XOR 0. So here I'll get 1, here I'll get 0, here 0, here everything would be 0. And XOR of 1 and 1 would be 0 because these are same. So instead of doing OR operation or something like that, I can simply do this to get the answer. XOR would be best here. So simply here I'll perform XOR operation. Okay, here instead of I it was J, and here it's K. Here it's M. So let's see now what will I do for this, for checking if my bit is on or off. It's really simple, guys. Suppose I got a number 1, 1, 1, 1, 0, 0, 1, 0, 1. Here all are zeros. If I simply toggle every digit, and I need to find this digit, I simply toggle every digit, then what would be my answer? 0, 1, 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1, and so on, 1. Okay, this would be my ones complement of any number. But if I do anything with this, then my answer would be disrupted. But if, guys, I take and now simply perform its XOR. So we know in XOR, if I am using 0, then I'll simply get the digit itself. So here it would be the digits itself. And here, when 1 and 1 both are same, so I would be getting 0. It would toggle. Suppose this was 0. Then 0, 1, because it's 0 and 1, they are different. it will also toggle itself and get me 1. So in any case, it would always toggle itself. If it's 1, then it will always become 0. If it's 0, it will always become 1. So it's easy, guys. Let's do this. I'll simply check if, let me move this line. Before printing, I need to check if n XOR my mask is not equal. Okay, that was toggle case that I have just discussed with you. But we need to find that if it's on or off. How we would do that. Okay, sorry guys, let me just go back. See, this was toggling. I have explained you toggling earlier also in function 3. Why I am doing it again, I don't know. So yeah, here. When I was supposed to tell you that if it is 0 or if it is was 1. Suppose it is 0 now. If I put a mask and do AND operation, then if it's 0, then I will get 0 here and everything else was 0. If it was 1, suppose if this was the digit, my mask come here. If it is 1, then I'll get something non-zero. Okay. So simply do the AND operation with the mask. If it's not equal to 0, then print true. Else print false. Let's run this. It's accepted. Get submit. I hope you like the video. Please like, share and subscribe to Pepcoding. Thanks for watching.